Hi guys, welcome back to my channel. Let's continue our revision. Okay, so today we shall learn, that means we shall do revision on fraction and real numbers. Okay, so what is a fraction? Okay, so a fraction means a part as a whole. Okay, so here we have a circle. Suppose this is a circle. Then if we divide this circle into two equal parts, then the shaded region is equal to 1 by 2. That means one part is shaded out of 2. Then here 3 part is shaded, 3 region is shaded out of 4. This is a circle and we divide this circle into 4 equal parts. So this the upper number is called numerator and the lower one is called denominator. So this is a fraction. Now we shall see proper fraction. So fraction means it is a numerical value of the form a by b. It can be 1 by 2, 3 by 4, or any numerical value of the form a by b. So this is a fraction. Next, proper fraction. A fraction where numerator is less than denominator is called proper fraction. Okay, see here, a is the numerator and b is the denominator. So a proper fraction means a is less than b, that means numerator is less than denominator. Example 1 by 2, 2 by 5, 3 by 4. 1 is less than 2, 2 is less than 5, 3 is less than 4. Next we see improper fraction. So improper fraction. Okay, here numerator is greater than denominator. A fraction in which numerator is greater than the denominator. Example 3 by 2, 5 by 2 and 8 by 5. Okay, see how we add fraction. Okay, so this is suppose this is a square, this is square, this is a square, and we divide each square into 4 equal parts. Then here all 4 parts are shaded. Here all 4 parts are shaded. Here only one part is shaded. So shaded region is equal to 2 1 by 4. How? This whole as a 1, this as a whole as a 1, and this is 1 by 4. So 2 1 by 4. Then this becomes 9 by 4. Here we can check 4 by 4. Here that means 4 part is shaded out of 4. Total 4 parts, 4 parts, and for all the parts are shaded. Here one part is shaded out of 4. So 1 plus 1, that means 4 divided by 4 is 1 by 4. 1 plus 1 2 plus 1 by 4. Then here 8 plus 1 by 4 9 by 4. So 9 by 4. Improper fraction. This is the representation of improper fraction. Then mixed fraction. So what is mixed fraction? A fraction of this form is called mixed fraction. Mixed fraction can be converted into improper fraction. How will we convert? How do we convert? Here you see 1 2 by 3 equal to 5 by 3. How we got 5 here? 3 1s are 3. We have to multiply 3 into 3, 3 plus 2. That means 3 into 1. Then you have to add 2. 3 into 1, 3. 3 plus 2 is 5. So 5 by 3. Here the denominator will not change. Then 4. Okay, this is another example. 4 1 by 2. 4. So 2 So 4 2 is 8, 8 plus 1 is 9, so 9 by 3, 4 into 2 plus 1, 4 2 is 8, 8 plus 1, and then 9 by 2. So this is mixed fraction. Now let's see like fraction. So 2 or more fractions with same denominator. So what is like fraction, or what are like fraction? 2 or more fraction with same denominator. Example 1, 1 by 3 and 2 by 3 are like fraction because here denominator, because the denominator of these two fractions are same. Here 4 by 9 and 5 by 9 denominator are same. 9 9, here also 8 8 8. Next, unlike fraction, 2 or more fractions with different denominator. Okay, here you can see 3 5 7 3 9 different denominator. Okay, then next let's see LCM. That means lowest common multiple. So how to find LCM? Okay, so 2 and 3 for number 1, 2 and 3, we know that 2 and 3 are prime. So for prime we just have to multiply. So 2 into 3 is 6. So LCM is 6. LCM. So LCM of 2 and 3. Okay, LCM of 2 and 3. How do we find the LCM? We find in this way by prime factorization 2 3. So this is prime. You have to first divide with 2, or you can divide it by 3. 2 1 is 2, 3 we cannot divide it, so bring it down. And then next by 3, this we cannot divide, so bring it down. 3 1 is 3. So LCM is 2 into 3 into 1 into 1. That means 6. So LCM of 2 and 3 is 6 because this is prime number, so we can just multiply. Okay, next 3 and 5. LCM of 3 and 5. We know that these two numbers are prime, so LCM is 3 into 5 to 15. Then let's see for number 3, 2 3 5. So their LCM will be, we know that these 3 are prime, 2 is prime, 3 is also prime, then 5 is also prime. So their LCM will be, you have to multiply all these 3. 2 into 3 into 5. So how much we got? 2 3 is 6. 6 into 5 is 30. Next question, number 4, 2 and 4. Here we know that 4 is the multiple of 2. So obviously LCM will be 4. Or we can check it. 2 4. So we have to divide it by 2 because 2 and 4 are multiple of 2. So 2 1 is 2, 2 2 is 4. So that's it. 2 is prime. Prime, that means we cannot go any further. So 2 into 1 into 2 equal to 4. So LCM of 2 and 4 is 4. Next, this one, 2 4 8. 2 4 8. LCM of 2 4 8. So 2 4 8. This 4 is also multiple of 2 and 8 is also multiple of 2. So here the greater will be the that means the greatest will be the LCM. So that means 8 will be the LCM of 2 and 4. Or we can check 2 4 8. So these are even number and we have to divide it by 2. So 2 1 is 2, 2 2 is 4, 2 4 is 8. This is 2, this is prime, but this is not prime, so you have to again divide, or 2 and 4 we can again go another step. So 2, this we cannot divide, so bring it down. 2 1 is 2, 2 2 is 4. Now here we can stop, or you can just do 2, bring it down, then 2 1 is 2. So 2 2 2. So we got 2 to 4 48. So our LCM is 8. Then next HCF, that means highest common factor. How will we find highest common factor? Highest common factor, HCF. Highest common factor. Okay, let's see highest common factor of 2 and 3. Here we have to list down all the factor. So HCF of 2 and 3. Factors of 2. That means we can write 1 into 2 and 3 as 1 into 3. So here common factor is 1. So HCF is 1. That means for prime number HCF is 1. Here same thing for question number 2, 3 and 5. Here HCF is 1. Then next 2 3 5, again 2 3 5 also same. 2 HCF of 2 3 and 5. Here HCF is also 1, because these three are prime number, or you can show it, we can show like this: 1 into 2, 1 into 3, 1 into 5. See the common factor, these are called a factor, and the common is 1 1 1. So HCF is 1. Next this one for 4. HCF of 2 and 4. So HCF of 2 and 4. 2 we can write as 1 into 2. Then 4 can be written as 2 into 2. 4 not here we cannot write 1 into 4, because in HCF you have to factorize in prime. That means this should be prime, and if you write 4 equal to 1 into 4, then 4 is not prime, so we cannot write this one. That means how you have to find, and how will you find this prime factorization? Prime factorization you have to do like this: 2 2 2 1. So 2 by 2. So here 2 2. So from here we have 1 2, and here we have 1 2. Take 1 2. So common. So HCF of 2 and 4 is 2. HCF is equal to 2. Then next for this one, this will be again 2. What then what's for 4? Then let's see for 4 and 8. HCF of 4 and 8. Okay, 4, obviously it is divisible by 4, so obviously this will be the HCF. But how will you find 2 into 2? 8 can be written as 2 into 2 into 2. For 8 we will find like this: prime factorization 2 4 2 2. So here common factor is this one, so 2 2, so HCF is 4. So HCF done. Next, sum of fraction. So here we have to add. So example number 1, 1 by 3 plus 2 by 3. This is like fraction, that means denominator are same, so we can just add the numerator. 3, write 3, then 1 plus 2, so 3 by 3, that means 1. This is how we add fraction. Then see for this one, 2 by 3 plus 3 by 5. Here denominator are not same, that means not like fraction, so we have to make it like fraction. That means we have to make this denominator same. So LCM, we have to take LCM here. So LCM of 3 and 5. So this is prime, this is prime, so LCM is obviously their product of 3 and 5. That means we have to multiply. So 15. So if LCM is 15, that means we have to multiply here by 5. LCM is 15, so we have to multiply here by 5. Why? Because LCM is 15, so to get 15 we have to multiply 5. We have to multiply this 3 by 5. So if we multiply denominator by 5, we have to multiply the numerator also, so that the ratio does not change. So just see, if we cut this 5 and this 5, this will be again 2 by 3. So the same way here, this is 3 by 5, we have already 3 by 5, so LCM is 15. So what we have to multiply here to get 15? We know that we have to multiply 3. So if we multiply 3 in the denominator, then we have to also multiply 3 in the numerator. So this is what 15, then write the product. 2 into 5, 10, 3 into 5 is 10, then 3 into 3, 9, 5 3 is 15. Then this is like fraction, so 10, like fraction, so 1, you have to write 15, then just add the numerator. 10 plus 9 is 19, so 19 by 15. The same way here, 1 by 3 plus 2 by 5, LCM is 15, so 15, so 3 into 5, to get 15 we have to multiply by 5, so we have to multiply numerator also. So 5, 1 into 5 is 5, 5 3 is 15, 2 3 is 6, so 11 by 15. Then here subtraction, 1 by 3 minus 2 by 3, so this is already like fraction, so 3, 1 minus 2, that means we have to just subtract this one, 1 minus 2, so minus 1 by 2, minus 1 by 3. How? Plus into minus, plus 1 and minus 2, plus and minus will their sum will be subtracted, but the sign will carry the sign of the highest number that means greater number. So here one difference of 1 and 2 is 1, but 2 is greater than 1 and 2 carries minus sign, so this minus sign will come here. Then next 2 by 3 minus 3 by 5, so take the LCM, 15 and 10 minus 9, and then 1 by 15. Then next here we have 2 by 5 minus 1 by 3, take LCM, so 15, 6 minus 5, 1 by 15. Okay, so now next is rational numbers. Okay, so we all know the definition. Any number of the form p by q, where p, q are integers and q not equal to 0, is called rational numbers. So example, minus 1 can be written as minus 1 by 1. Then 25 we can express as 25 by 1, then 7 by 8, 2 by 3. Okay, so these are rational numbers. every integer is a rational number. Why? Because every integer can be expressed in the form like this. Here we can express, suppose we can consider any integer, suppose negative integer -5, then we can express this as, or we can write this as -5/1. Okay, rational number. This is in the form of p by q. Q is equal to 1. And then also for suppose positive, say same number 5, then we can write 5/1 or 6/1. So every integer is a rational number. Then there are infinitely many rational numbers between any two given rational numbers. Yes, so between any two rational numbers there are infinitely many rational numbers. Say for simple example we can take between 1, suppose this is a number line, this is 1 and this is 2. Then between, suppose this is 0.5, there we can write as 5/10. So this is rational number. Okay, this is rational number. Wait, this is 0 and 1. 0 and 1, this is rational number. Then 0.6, this is 6/10. Here you can reduce here, 1/2, then 3/5. This is rational number. Then here next, suppose 0.7 means 7/10. Okay. So these are rational number. Or between 1 and 2, here the middle one will be 1.5. That means there will be how much? In terms of fraction it will be 15/10. That means 3/2. So this point is 3/2. Yeah. And suppose this is 1.6. So 1.6 means 16/10. So this will be 8/5. This is also another rational number, p by q. There q is 5. So between any two rational numbers we can find infinitely many rational numbers. Then next, decimal expansion of rational numbers are either terminating or non-terminating recurring. That means what? Decimal expansion. Consider any rational number of the form p by q. Suppose 1/2. When you divide it, you will be in term of decimal, it is 0.5. So next one is non-terminating recurring. For this we can consider a rational number. That means let's consider suppose 1/3. So if we divide this, then 1/3 is equal to 0.333. It will be 0.33333. Then this 3 is repeated. So this is what? Non-terminating. That means the remainder does not become 0. And this is repeated. The same number is repeated. 3 is repeated. So it's 0.3 recurring. So this is also what? Rational numbers. So from this we can know if a decimal number, that means if any number in decimal form is either terminating or in recurring form, then we can say that these numbers are what? Rational numbers. Otherwise it is irrational. Then for irrational, what are irrational numbers? Any number that can be written in the form of, or that cannot be written in the form of p by q. P by q, p, q are integers, q not equal to 0. Say root 2, root 3, root 5, pi, and this are what? Irrational. Why root 2? You can check it. You cannot write root 2 in the form of p by q. Okay, yes, we can write root 2 by 1, but root 2 is not an integer. Suppose consider root 4, then we can write as 2, considering only the positive value. So 2 by 1 we can express in the form of p by q. So this 2, that means root 4, it is what? Rational number, but root 2 is not an rational number, not a rational number, it is an irrational number. The same way pi and 0.1, this one 0.1011011110. okay, this is not repeating here. Number 1 is 2, 3, and number 1 is 4. It will go on like this. So next, real numbers. Okay, what is real numbers actually? So real numbers, it is a collection of rational and irrational numbers. Okay, that means both rational and irrational numbers we can call real numbers. We can call rational numbers as real numbers and irrational numbers as real numbers. Both the numbers are real. That means both that, so here definitions is like that, a collection of both rational and irrational numbers. Okay, so we have a point, important point, that means we have to note this one. Every real number is represented by a unique point on the number line. Also, every point on the number line represents a unique real number. That is why we call the number line the real number line. That means what? Every real number is represented by a unique point. That means if you consider, suppose this is a real number line, then if you consider any rational number, that means you can represent on the number line. Suppose if we consider half, that means here, then this will be 1, so half will lie here, 1 by 2. Also, every point on the number line represents a unique real number. That means every point on this real number line is what? Is a real number. That means every point on this number line every point on this number line, every points on this number line are real numbers. Okay guys, so that's it for today. Okay, si lang pon tu kui nang nadak fraction plote lage kuson any number of this form fraction, that means at chat chotlo lage 1 by 2 ladak bangke 3 by 4 last division hano athak panke numerator polo abyara phan bangke denominator polo. Proper fraction e kuson lo athak numerator bangke denominator pe dichaplo. Nalote proper fraction a is less than b. Improper fraction abangke numerator c akitepo numerator is greater than denominator. It is improper fraction. Mixed fraction equation fraction of this form like a mixed fraction. Mixed fraction can be converted into improper fraction. Mixed fraction ke improper fraction itum convert on. Question lajong si mixed fraction na polote itum la pen la into nang po anke la phan bang plus 10 na po 3 1 is 3 3 plus 2 is 5 here 4 1 by 2 2 4 8 8 plus 1 is 9 9 by 2 arum bangke denominator ke same po next bangke like fraction polote denominator same nang dila lote like fraction no 9 9 8 8 next unlike fraction denominator bangke same ke different denominator next LCM kosong sekian no LCM ladak bangke latum ke prime lo plote multiply fit nang po prime lote multiply fit nang po product lo ladak bangke 2.4 LCM ke 2.4 ke kosong po LCM 2.4 tum hini da 4 pen divide on lasi or 2 pen divide on lasi 2 pen divide on 2 1 pen ke divide on 8 nang pasun tung non 2 1 ja 2 LCM ke 4 2 into 2 2 into 2 1 pen ke into 1 pen da chong lo so LCM is 4 dak tala sonak thalo dak bang ke 8 po next sum of fraction sum enang po lasi sum of fraction datum fraction kosong si ke plus po lalo pote 1 by 3 2 by 3 latum fraction pote latum ke like fraction aber denominator ke same lalo pote la thak pot plus dok cholo 1 plus 2 aber ke lai si tok nang po 3 ni polisi tok nang po lalo te 3 by 3 latum ke divide den non 1 long po so na thak si 2 by 3 plus 3 by 5 LCM ke 15 latum phan like fraction pinchong nang po ke chenge kosong na pinchong is LCM den non 3.5 LCM ke 15 and ke da ke 2 by 3 ke dotang lo so 15 ke palang pani tum chini 5 multiply na bo ase denominator jong si 5 pen multiply la polote numerator da 5 pen se multiply na bo lalo dakta sunak thalo 5 ke dotang lo 3 by 5 ke dotang lo 5 la 15 ke palong ye phanda ke tum 3 multiply na po apere multiply ta thakta multiply na po lalo polote la into non a product on that 3 5 15 2 5 10 santhalo 9 by 15 next bangala tum ke like fraction lo 15 tong non athakot plus tong non 10 plus 9 19 so nak thak sidak tala sono 1 by 3 plus 2 by 5 LCM ke tum sini lo 15 5 3 15 ni palang pani tum 5 multiply nang ko si 3 into 5 then means athakta multiply nang ko 1 into 5 5 into 3 15 2 into 3 6 11 by 15 dakta sonak thalo dak bangke minus lo 1 by 3 datum ke minus lo 1 by 3 minus 2 by 3 LCM ke 3 lo like fraction attack on minus 1 minus 2 ke minus 1 so minus 1 by 3 sign convention lo plus pen minus plote minus lo sitami assign mangke kolo se ke thema kolo so number se ke thema so long assign sang ko dake 2 se ke the 2 long ke minus sign se do ase minus 1 se lang 2 minus 1 ke 1 lo sitami minus ke 2 long se do that means 2 se ke the la se 2 long ko pe sign mind do se lang po Angkala yang cholo equivalent fraction polote 1 by 2 letung lapang 1 by 2 angke tum 2 by 4 potong me laki equivalent fraction 5 by 10 stamina tai to 1 by 2 reduce equivalent fraction the next lang konan next ke rational number ko son lo isi number itu yang si ajat number tami p by q form yang si tokon polote angke lagi rational numbers lo PQ के integers Q बन के 0 kali la any number dolong pada ke next minus 1 kan itu minus 1 by 1 potong ni 25 and 25 by 1 tong ni dapat 7 by data isi fractional la ke rational lo okay next one ke ila okay every integer is a rational number integer put it in lo minus 1 minus 2 minus 3 0 1 2 3 4 hai below rational number integer lo lasi latum ke rational every integer is a rational number itu mathe rason tong me integer aphan item suppose 5 integer lo 5 by 1 tong me 6 integer 6 by 1 tong me asi anta rational there are infinitely many rational numbers between any two given rational numbers between any two rational number item rational numbers long use item lang na suppose between any two is example 0 pen 1 so that rational number dolo sudata 0.1 into 1 by 2 ang bong 0.5 that means 1 by 2 but I see rational number 1 by 2 ke rational number athela ke q by q formula q not equal to 0 q ke equal 0 kali anke 1 by 2 1 upon 2 divided by 0.5 plus nalo da kapre ka number doji infinitely many rational numbers suppose itu 1 10 5 ang bong nang rational number to below 2 3 4 the rational number lo irrational number to lo the next one ke decimal expansion of rational numbers okay decimal expansion of rational numbers are either terminating or non-terminating recurring মানে rational number अपन इतुम जों सी क्वेश्चन decimal form तंजी बोलते हैं लास्ट में decimal form के लाते मांगे terminating that means remainder 0 long वेजी divide लो बोलते खाली बोलते इसी का हम repeat लाइन दैट पर असम के recurring को asi alasan na number जों सी थेक्लों लो बोलते लगे rational number पुसी नंग को जों सी terminating that means जुट को लो that means divide लो बोलते 0 long suppose इतुम 1 by 5 1 upon 5 and divide log low take 0 by 2 is 10 that means remainder 0 long so 0.2 0.2 but I see rational number so not irrational ko itu yung si p by q form talk no polo te balance talk un e polo laki irrational root 2 root 3 root 5 pai lapen lata kalang lo theta ke chu de non-terminating pina lapen recurring kali da jong si non-terminating recurring bolte rational number lo asi real number mai ko sono real number bolte rational pen irrational lapang rom pen apan si real numbers product rational ta real numbers lo lapen irrational ta real numbers lo okay every real number is represented by a unique point on the number line that means bila every real number itum ajat a real number like consider stami ajat real number and stami itum number line no represent on number line no itum represent on suppose like 0 lo like 1 lo itum suppose real real number and 0.5 okay dak lo itum represent on suppose 1 tami si real number no dak itum 1 to on lo represent on lo so nak lo every point pindu next labang ke every point on the number line represent a unique real number that means ada a point gitu an la real number line la so number line long la so a number line long every point kami pila real number every point kami so pila type okay every point on the number line represents a unique real number person lage every point that means appointing sitami real number lo ang itum real number long po appointing long sitami isi real number long po asi la so number line pan kipila itum real number line puta lo